Ever wondered about the incredible power of black holes? We've marveled at their ability to ensnare even light. But imagine this black hole not only capturing one galaxy but 6 entire galaxies in its gravitational grip. This mind-boggling feat challenges our understanding, a colossal entity, 1,000 times the size of our Sun, weaving its influence over an area 300 times faster than our entire Milky Way. Yet, this extraordinary display only scratches the surface of the enigmatic world of black holes. Is it possible that our comprehension is just a shadow, and these cosmic behemoths harbor even more astonishing secrets within the vast canvas of the universe? Let's delve into a fundamental question: what's inside a black hole? Picture this: entering a realm where the normal rules of space break down completely once you cross a specific line known as the event horizon. Escape becomes impossible, but what lies beyond that line? Is it an empty void, or does something more mysterious lurk within? When objects get pulled into a black hole, do they vanish forever, consumed by a cosmic vacuum cleaner? And what about the singularity at the black hole's core, a superdense entity that begs the question: is it a portal to another universe? These are not easy questions. Can we ever uncover the truth about what transpires inside these dark giants? Do they hold the secrets of the universe that have eluded us for so long? And how does all of this reshape our understanding of space, time, and everything in between? But before we unlock the mysteries within, let's first understand what a black hole truly is. Predicted as a mathematical solution to Einstein's equations, black holes emerged as an outcome of the interplay between matter and the shape of space, as described by the theory of general relativity. In 1915, Karl Schwarzschild crunched the numbers and laid the groundwork for black holes. Initially met with skepticism, their existence gained credibility as we discovered other cosmic phenomena, such as neutron stars. The birth of black holes occurs in two ways: through the collapse of massive stars or the direct collapse of gas in the early universe, giving rise to even more massive black hole seeds. Now, let's tackle a mind-bending concept: quantum entanglement. Initially dismissed as absurd by physicists, this phenomenon connects particles across vast distances, transcending space and time. This entanglement plays a crucial role in understanding black holes, especially when it comes to Hawking radiation. As Hawking radiation consists of entangled pairs, it introduces randomness, making it challenging to infer the black hole's contents. This randomness, termed entanglement entropy, grows with each emerging Hawking particle, plateauing as the black hole evaporates. This pattern, known as the Page curve, presents a challenge to physics, creating the information paradox, an apparent conflict between the principles of quantum mechanics and the preservation of information. To unravel this paradox, physicists explored various solutions, eventually considering the interaction between Hawking radiation particles and black hole interiors. This led to a groundbreaking revelation: temporary wormholes near black holes. These wormholes, part of the island formula, effectively swap out the interiors among different black holes, resolving the information paradox and supporting non-locality. In essence, these discoveries suggest that black holes, far from being mere information shredders, follow the intricate dance of quantum mechanics through wormholes, preserving information in a way that aligns with the principles of entanglement. As we continue to explore the implications of these revelations, we're just scratching the surface of the profound connection between quantum mechanics and the mysterious nature of black holes. The journey to understanding the cosmos is far from over, and the revelations within black holes open new doors to the wonders of the universe.